Now we're going to look a little about model predictive control. It's a fairly new, it's for a long time, method of controlling a product. So its model is prediction. So let's a little look at this. So here we are looking into the future. It's prediction. So you're looking into the future and say, how should we control the process? What kind of control signals should we out to the control values should we out to the process to have a desired trajectory or something, or approach a set point that we want. So the objective is to minimize the control error. And then there are some constraints. We can't do whatever we want. A constraint is that we have maximum and minimum control values. I can't output 1000% control value. I don't have that much power. And then it's also maybe a constraint that I shouldn't use too much power. So I shouldn't be too vigorous on my control valve or control values and things like that. Here's a Nestor on this. He has a video YouTube playlist. So if you watch the first video, you get a really good understanding of what let's say model predictive control is. Maximum overshoot. And the prediction must be long enough. For instance, the car again has at least covered the next curve, or else you're just going to go straight into the ditch, which you don't want. So what we have here is a system. We have a process. We have control values to the systems, and we get process values out. One controller, more control values. And here is our MPC digital. It could be a digital system, for instance, a PLC. So we have a system model, a state space usually. It looks something like this. This model is something that if we have a system model, often we don't have a system model, we could use system identification to obtain the model or something, but we need a model. If we don't have a model, we don't have a model predictive controller. It's as easy as that. So what we do here is that we use this equation. What we want to look at is this use. Let's say our control values. What do they have to be in the future to achieve what I want to do? And I need some kind of an optimal equation or something. I need something that I want to optimize. Obviously, the error has to be slow or something, low or zero or something. That's my optimal criteria. And what do I have to do to achieve this? Zero error, no overshoot. Yeah, I get to zero error, but my process value went to 250% and my tank emptied or whatever, on its way towards zero error. So it's this use in the future I want to do. And what I do is, and then I adjust it using a model adjustment, a state estimator, usually a Kalman filter. I can be used. So if my model is not completely correct, I adjust it based on process values. So I adjust my state-based models to get more correct. And also I compute for my horizon all the way, but I output just this one, and the next time I compute this one. So it's a computing iteration all the time. So when I do the manipulation of this matrices and constraint matrix or whatever, I end up with a huge matrix with these future control values. So I want to optimize for all of these. So this equation, it's a differentiation or an equation or stuff like that, but I want to solve it for zero. So I should put values in here so that I've solved this game. So these are my unknowns, my X's that I have to find. It's huge, but sparse. There's a lot of zeros, and 0 times something is always 0, so I don't need to do that calculation. It's computer intensive because they have to solve it for each sample that they do. Yeah, so straightforward Gaussian elimination to solve an equation system like this might not be feasible. So PLCs, here's a schematic again. MATLAB has something called a PLC coder. So MATLAB, you made the MPC in MATLAB, and MATLAB generates structured text code that you can download, use the portal, Semantic. You can generate code for other systems, use the IDE for the system, download to your PLC, and if the PLC is fast enough and can solve this matrix, you are good to go. But these calculations, some of these calculation and matrices that it has to create can be pre-programmed. MATLAB can construct these matrices, so each time you don't have to construct them in your program. So you have to do the calculation that's only necessary to find this use. And then you output the first one. In the next sample, the 2 is become 1, and you calculate for the 2, the next step, and so on. And here is there's a horizon. That how far do I have to look to make this work? Yeah. Really quick on model predictive control. Just an overview. It's complicated and it's computer intensive. You need a tool to set up, like MATLAB, to set up a model predictive controller. And you need, if you want to put in a PLC, you need a code generation. Don't try to program such as it's possible to program such a system like this in a PLC. Of course, MATLAB, they have made code for this. So it's possible to code something in a PLC to do this. But it's better to use a mathematical program like MATLAB, or if there exists a library for Python, use that.